Well, good afternoon. Try to keep today's video short and quick. I know we haven't been doing videos lately, but again, it's a Wednesday, 30-minute day. I'm not going to make you do the Zoom today. So again, short video. So the sum rule. Well, this one kind of follows pretty obviously. If we're doing the derivative of two things being added together, like a polynomial, then we can do the derivative of each part separately, and then just keep that symbol in between. So for example, f of x equals 3x squared plus 5x plus 6, what we can do is do the derivative of just this first part, and then do the derivative of the second part, and then do the derivative of the third part, keeping those plus signs in between. So based on what we learned yesterday, I would do the constant multiple rule, that this exponent 2 is going to go out in front times by that 3 that's already there, giving us a 6. And then I subtract 1 from that power of 2, which gives me a power of 1. But you all know we don't write powers of 1. And the second one, there is no exponent on the x, but technically there's a 1 on that exponent x. So I'll take that exponent of 1 and times it by the 5, which will still be 5. And then I'll minus 1 from the power of x, which would give me x to the 0 power. But hopefully, again, you all know that we don't write anything to the 0 power. So that part would not be necessary. And then last but not least, when we take the derivative of a constant term, we always get 0, which is not really necessary either, so we don't need that in our final answer. So the final answer is that f prime, or the derivative of f, is equal to 6x plus 5. And again, what that is the way to find the slope of the tangent line to this original equation at any particular point on the graph that you want. If you want to find the slope of the tangent line at x equals 5, plug 5 in for x. If you want to find the slope of the tangent line at x equals 0, plug a 0 in for x. So once again, that gives us the slope of the tangent line at any given point, not at just one particular point. All right, let's try another. Alright, so I'm going to do the, again, derivative of each individual one. And I'm not going to write the big, long nastiness. Alright, I'm just going to go ahead and do the derivative. So on this first one, exponent 3 needs to move out front as a new coefficient, where it will times with the current coefficient of 10. And then that x has to drop its exponent by 1. 3 minus 1 makes 2. And then I can add to that and do the same thing with the next piece. The next term can do its own little derivative, where again this 2 is going to try to move out in front, times up with that 4 that's already out there for 8. And then the x is going to drop its exponent by 1. Next one, you don't see it, but there's an exponent 1 here. Times it by that 6 that's out front and stay 6. And then we'll minus 1 from that power, giving us x to the 0. Oh, wait a minute. That's right. We don't write 0 powers. The 6 stays, but not the x to the 0 power. And then the last part, the derivative of a constant function is just 0. Now, of course, I wouldn't need that piece either, so there's my final answer. Let's try one more. Alright, again, the derivative. And if you'd like to use the other notation, you can use the other notation. If you'd rather use f prime of x, doesn't matter. Alright, so again, this 5 is going to try to go out front to be a coefficient, where it'll times up with that 6 for 30. And then the exponent drops by 1. And then this 3 is going to go times out in front of that 2 to make a 6. And then the exponent drops by 1. And then this exponent 1 goes out front, times this by 9, which stays 9. And then x to the 0, which just kind of cancels. And there is the function for our derivative. Alright, let me know if you need any help. Good luck.